Good afternoon. I think this is Q23. It's my privilege to be the moderator for this session. My name is Dave Schwaderer, ShapeShift. I'm the guy asking all of the obnoxious questions in the sessions. Our first session, we are very, very privileged to have John Gray. He has worked in the computer security field since 2002. That's about 20 years. Senior designer on the Entrust PKI team. Entrust, a great, great company. Development team that specializes in development of a Java-based FIPS 140-2 Level 2 cryptographic toolkit, which is used extensively within the organization and by external customers. Please give John a warm welcome.
Hello, everybody. Thank you for coming today. Lately, I've been working with standards and adding PQC into our products, and working with a whole bunch of people, like in the IETF. So, this is what I get to talk to you about today: is our PQC Interoperability project, which is really another word for it is the IETF Hackathon project that started in 2022. So today, I'm going to talk to you about that project, the goals of the project, the current project output that has happened to date, and the recent updates that happened in the last IETF. We had some automated tooling, which is really exciting, and I'll show you how that works. And then the last part I'll talk about is how you can get involved, and how you can do PQ interop testing in 3 easy steps. So the project, so back, was it around 2022, I think it was in London, at the IETF 115 hackathon, we said, wouldn't it be fun if we could, get together and we work in the LAMPS working group, which does all these X509, ASN1 structures that everyone loves, all that stuff, right? So we do that, and can we get together and start using this PQ stuff? Of course, at that time there was no standards, so nothing. You couldn't talk to each other because we didn't have object IDs and things like that. So, but now that we have standards, this kind of gives us a new footing going ahead, but there's new things coming, right? So this project just keeps going. So anyway, we started back in November of 2022, and then we had such a fun time together with the group. We made good progress, which I'll show you in a minute, and it just kept going. And we started having monthly meetings, and then went to the next hackathon, and just keep adding to that. And then about 6 months later, we got involved with the NIST NCCOE. In our first meeting, I remember going to that, and they're talking about the interoperability performance work stream, and we were invited to that. And they were already talking about this project, this hackathon that was going on IETF for PQ, and it's like, oh, I can tell you about that. That's what we've been doing. So it's really great to work with them. There's been lots of discussion about NCCOE and how great collaboration that NIST has, and so it's great that this project can be part of that as well. So for the goals of the project, I mentioned before, initially it was just we wanted to get together, create some certificates, and make sure that if I send you a certificate, you can verify it, and if you send it to me, I can verify it. That was kind of how it started. But then we also wanted to test interoperability between different implementations, of course. So the more people that join, the more different, the variety of implementations you're going to get. And so we wanted that as well, and we did. More people started coming. Also, we wanted to gain experience using these PQ algorithms because, they're still new, right? And there's still new ones coming, so of course that helps as well. And also the next one, because it's part of the IETF, we want to give feedback to the standards bodies, right? So lately, we started with certificates, but we've also been starting to look at a lot of the LAMPS working group drafts. I talked on Tuesday about different certificate mechanisms for transitioning to post-quantum cryptography. There's a number of things there, so a lot of members wanted to actually kind of basically hack together implementations, and let's get some concrete, examples of how does this actually stuff work? Does this actually solve the problems that we're looking at? And then, the other thing that's really cool I didn't mention here that maybe it's kind of a goal is because it's bringing people together. We start talking and we have ideas and we're like, oh yeah, we have this challenge. Oh, okay, you guys have that challenge. Let's get together and talk about this. And then even from that, some new drafts have happened. So that's part of the goals of the project. So the project outputs. So when we started, So the IETF has this nice repository in GitHub, and so we said, oh, can we just make use of that? Because the first thing was, if I'm going to test with someone, I need somewhere to know how to get it, right? Like there has to be some kind of database, and it's like IETF has one. And the other great thing is IETF is open, right? So anyone can use it. Obviously, you have to have access to it, but it's easy. There's no encumbrances to that. IETF is very open that way. So if you wanted to look at the project while I'm talking about it, you can, so I have the link here, but if you just go to Google or Bing or DuckDuckGo or wherever your favorite search engine is, just type IETF space GitHub space hackathon, and then there'll be, there's a bunch of projects. Ours is at the top because a lot of people use it, I guess. It's called PQC certificates. Just click onto that. You can do that now if you want, and then you can just kind of follow along all the information about the projects there. But essentially, so we started with that GitHub. First thing we did is define a zip format, a very easy to use zip format with how to test the artifacts. So I'll show that in a second, what that format looks like. And then importantly, I mean, the other thing was, if I'm going to talk to someone with a certificate, how do I do that if I don't have an object ID? So until recently, at least with the standard algorithms, we didn't have OIDs, right? So we had to decide as a group, okay, let's agree on a table and publish that, and then other people can use that. So that's been a really good outcome. And like Jim mentioned earlier in the session a couple hours ago, like some other groups have used those OIDs as well. It just provides a way that we can talk to each other. So that's been a great outcome. The other thing on the right-hand side, so we have in the project, if you're actually there on the page, so I encourage you if you want to go there, there's a folder called Providers. These are basically someone that wants to join the project, just make a folder, put your name on it, or your company or whatever, and then that's where the artifacts go. But so far we've had 15 different providers join us. So you can see on the right-hand side, like BC is for Bouncy Castle, we have Botan. There's a number of individual contributors, so Carl Wallace, some of you might know him. Yeah, so open source or proprietary. So there's been 15 of them, lots of different languages represented, Java, C, C++, Python, and Rust. And we also published the results in the compatibility matrix, which I'll show you shortly when it gets to the exciting part. So yeah, so this is an example artifact repository format. So this is one for certificates. We also have ones for CMS, and yeah, I'll get to that a bit later. There's also people that want to add different protocols and stuff too, but this is kind of where it all began. We said, okay, what's the simplest thing if we want to test for signature as well? A certificate has, you know, a public key in it, and you can verify it, and obviously you have to generate a private key to do that. So if you can verify a certificate, a self-signed certificate, then it's likely indicate that you can support that. So basically we said, okay, just for whatever algorithm you're using, so this is signatures again, we started with signatures. Create a self-signed certificate. The kind of like the fields of the certificate don't matter too much. It has to obviously be a valid certificate, like, you know, but the actual data in it and the name doesn't really matter. It's more the signature, that's the part that matters. So define that and just use the object ID and then dot, and then we were using PEM format before. So you see here it says new, because we just, with the new standards coming out, we decided, yeah, it's probably time to fix a couple things that were a little bit problematic. So if you look on the right-hand side there, the example older VP3 format, so you just see a bunch of these numbers, right, .pem. And like, I know what some of those numbers mean. Those are like the prototype OIDs I was talking about, but it's not really friendly, right? So like the 13999.3.6, that's a Falcon prototype. I happen to know that, but I mean, it's not easy. So we thought, okay, for the new artifact format, just have a friendly name at the beginning and then dash the OID. It just makes it easier, right? The other part I highlighted there is .dir. So it's underscore TA for trust anchor, so that's a self-signed certificate, and then dir is for dir format. Because one of the issues we found with interoping people is that I guess it's hard to do PEM formats correctly. Like it's base 64. We thought that would be easy, but we ended up having a bunch of interop issues just with the base 64. So we decided, okay, we're going to get rid of that possibility. We're just going to change it to dir format. So going forward, it's a dir format. The second thing, if you want to do an entity certificate, that's like ML Chem, which would be now, I guess the slide's a bit older, it has Kyber 512 in there. Have your end entity signed by one of those self-signed routes. So we decided the dilithium 2, which would be MLDSA 44 for the new one. So anyway, that's basically the simple artifact format that we defined. And so then going forward, so this, we have a lot of OIDs represented here. So this, we just updated this like 2 weeks ago because obviously the new standard came out August 13th, and then it was only about a week later that NIST came out with the final OID list. So thank you NIST for that, because we've been asking for that for like many years. So now we actually have some standard OIDs that we can test with. So going forward, people can actually do interop testing with the final standards. We haven't added the pre-hashed ones yet, but obviously we're going to do that because people are going to want to test that. So we have more than that though, right? Because we know the round 4 CAM algorithms, for instance, are coming. So these ones here, Bike, HQC, Michaelis, they can be tested. Those are prototype OIDs again, because again, they're not standardized. And we've kind of, with the group, we've kind of have this unwritten rule, well, not really unwritten rule, but the first one to test or submit an artifact kind of gets to define what the prototype OID is going to be. And you can see it mentions Bouncy Castle there, because if you guys know David and the Bouncy Castle team, they always pretty much, you drop a standard, the next day they'll have something implemented. So anyway, kudos to you, David, for doing that. So a lot of these prototype OIDs actually are coming from them, but we agree to use them. So, and also in Entru, we had some interest, some people joined the group that want to test with Entru, so that's fine. So we have some prototype OIDs for that as well. The other one I'm involved with standards is composite signatures. So that's a hybrid format combining, PQ and classical key together. So we can fully test these things as well. So these are based on, this slide is wrong. The specification is actually the adopted draft version 02. So we have composite signatures and CAM. So there's 13 variations. So this is testing the different combinations. So we have both of those. So that's great. So now you probably want to know, like, okay, well, what does this look like, and how can this work for me? So this is an example of what our compatibility matrix looks like. So this was taken a couple weeks ago. If you go to that page now, if any of you actually typed in IETF GitHub Hackathon into Google and went to the page, you can, if you've clicked on this, it might look a little bit different, because anytime someone submits a new artifact, like asserts, it's actually underscore v3 is what the automated GitHub tooling, I'll show you in a second, actually uses. It's going to update these tables, right? But this was a view from a couple weeks ago. So again, at that time, there was the initial public draft version. So we have the names there. It's kind of hard to see probably, but like the top 3 are MLDSA IPDs. And you can see in a fair number, like we got the green check marks, that means they work together. If there's nothing in the table, it means it wasn't tested. And if there's like the empty circle, it means it didn't work. So you can see even at the bottom, the composite ones, that's a hybrid one, right? There's actually a fair bit of support for that. So we have Bouncy Castle, we have CryptoNext, Entrust, and OQS Provider actually mostly support that one as well. And of course, there's the SLH DSA as well. So this was the first attempt at doing the automated tooling. So I'm just going to show you talk a bit about, so that's what happened in the last IETF 120. So 2 of our members, so Mike Owensworth and Felipe Ventura, actually worked on adding automated GitHub actions so that if you submit your artifact zip file, it can actually unzip it, and then it would run it against the OQS provider artifacts that were already there and do an automatic update of that table. And actually, this came about because, we don't want to be like, we want to interop with everyone, as much as we can. So we talked to, about 3 months ago, the PKI consortium, because they maintain a list of, kind of volunteer list of, vendors and companies that say, okay, we support this algorithm, we support that algorithm, we support this one. And so we had a discussion with them, and we said, well, wouldn't it be great if, we could all work together? And it was actually, I think it was one of the members for there said, well, wouldn't it be cool if you could do some kind of automated kind of tooling that would, be able to test these things automatically? So we put a GitHub issue into our repository to, okay, this would be cool if someone wants to do it. And then that's what Mike and Felipe did at the last IETF Hackathon. They spent 2 days and they got it working with just the OQS. And then, of course, that's the first one, but then we could add other open source ones, right? So then we were talking to David Hook just a couple weeks ago, and we was like, we would like to get Bouncy Castle there automated. So if you know David Hook, you know, you give him a challenge. Well, the next morning, we had a way to add that into there, using, because we need like a Docker container and built into that. So he had done that, and then we got that built in there as well. So now, if you submit your certs file, you'll actually be tested against Bouncy Castle as well. So that's pretty cool. The other thing you see at the bottom here is we had a person come at the last hackathon, which I guess is Joseph Lukfar. So we had a GitHub issue that we submitted as well. So the NIST ACVP tests, like when they're run, right, they have a code base. So that code base, like could we take that code base and make certificate files from that and then submit that as an artifact and then have that automatically run? So he actually took that on, so that was a GitHub issue. He got pretty far, so he was able to generate certificates using that code base. So the next step, of course, is to add that into the automated tooling. So once we have that, that means we'd have Bouncy Castle, libopen quantum safe, and NIST ACVP test vectors that could be run automatically when people submit. So that will be really cool. That should come. And so then and I'll show you in a second. Actually, probably the next slide. Okay, I'll get to that in a minute. But once that's possible, within a few minutes of you submitting artifacts, you'll already know if your algorithm looks like it's working with those different providers. Oh yeah, the other thing that we have as well, so we've also so the OID mapping table I was showing earlier, we also have put that into a portable JSON format, so a number of vendors, right, like, so that makes it a little more, I know some people don't like the word crypto agility, I heard from earlier today, but you can take that JSON file and that is generated from the markdown file that has our OID mapping table in there as well. And that's actually what's used to do some of the automated table I showed you earlier. So bonus material. So I mean, again, I said this started with just certificates and us having fun together and let's get certificates working. But then some people are like, well, we want to test CMS with this. So there's actually a format. You can look on the page. If you've actually typed in IETF GitHub Hackathon and you've gone there, you'll see we have a format for how to submit if you wanted to test CMS as well. So you can do that as well. We have a member of the group from Siemens, Alexander Raelian. He's interested in CMP, V3. That's a spec we're working on at IETF. So he's defined a bunch of the formats for like the enrollment protocol messages. Also, we can do OCSP and serial. So we don't have automated tooling for like CMS and these other things yet, but it's totally possible. We've shown that it can be done, and I think it will happen. So it's a community effort, right? So the more people that add to it, the more valuable it gets. So right now we have a lot of success, but the more people that want to participate, or if you have another protocol you want to test with this and you're okay with defining a format, then come do that. The other thing I mentioned a bit earlier is we also, a bunch of us in our group, were working at the PQC migration mechanism. So like actually, and I talked about, I think, most of these on Tuesday. There's a few that I didn't. And there's more than this in the LAMPS working group, which sometimes we joke should be called the AMPS working group because there's so many things going on in that group. But a lot of members are, they might have a draft or something and they're like, oh, and it's to do with PQC, right? So there's a lot of things coming, obviously, now with the standards. It's probably going to even amp up even more. But so a lot of those providers have provided artifacts for these different mechanisms as well. So if you want to test one of these or look at what a chameleon certificate looks like or what a composite certificate looks like, you can do that. The other thing is we're starting to have some discussions about MTL use cases too. So there might be some more stuff coming there. And so this is where how you can join and be involved. So in 3 simple steps. So if you wanted to see if you have an algorithm implementation and you want to see if it's interoperable with OQS or Bouncy Castle or any of the other ones. So generate a self-signed PQ certificate file. So like I showed that format earlier. So _ta.pem, put the OID. Even if it's only one, it can be one or it can be multiple. Put that into a zip file, and then you have to name it the specific name. So this one's artifacts. There's R4. Again, R4 doesn't do the automated tooling yet. It will after our next hackathon, or maybe even before then. So right now it would be R3. So it's just a slightly different format. It's listed on the page there. So again, you can look that up on the GitHub repository. So you do that, put those in there, and then you essentially create a provider location. So there's the link there to the PQC certificates. So you can make a folder for that provider location. Then you just upload that zip file. So on the GitHub page, you can just upload it. And then as soon as it sees that that file name matches, it's going to start running the automated tooling. And then within literally 2 to 3 minutes at the most, it will actually update that matrix. And then you'll actually be able to see your results right away. So you'll get something that looks like this with, another field for what you've added there. And then you'll see if there's check marks there or no check marks. And so we think that will add a lot of value to the community. And I guess my time is running up, which is good because I'm near the end. So this project wouldn't happen without all the people that have involved. So I know this hasn't captured everyone, but at IETF, we do have a lot of fun. It's kind of funny. We support people that are remote too. So even if you can't come to IETF, we're fully open to being remote. And in fact, I think the people that are remote get more work done than those of us in the room at the hackathon, because usually we're talking and stuff like that, right? But there's a lot of interesting ideas can come out of it as well. So if it wasn't for all these people, this project wouldn't have happened. And so our next steps. The first Tuesday of every month, we have a monthly meeting. It's I believe it's 8 a.m. EST. So if you want to get involved, just ask me. My name is john.gray@entrust.com, or send me an email. You're welcome to always attend the meetings. Our next hackathon is scheduled for November 2nd and 3rd. That's at the IETF. And of course, hopefully you've all typed in that page, and if there's the link there. But IETF GitHub hackathon, pretty easy. PQC certificates, and then you can find out all the details. So I would just say join us. Some of these pictures are just from the IETF. I think at one IETF we had 3 tables of people going. On the left-hand side there, that's kind of we have scheduled meetings for the remote people, so that they don't feel like they're just on their own, right? So we actually get together even while people are at the meetings, and it's really cool because collaborations even in person and remote happen, and cool things happen from that. So that is it. So happy to take any questions on this. It's a really fun project, and we had a lot of fun.
So John, first of all, thank you all for your significant contributions. And I am, as a moderator, I am now soliciting questions from the audience. If I can get this microphone. Yeah. Are there any questions?
So it was crystal clear. That's good.
Crystal clear.
No one needs to ask anything. Super. If you want to join, just send me an email. I have my email there. Yeah.
Thank you for your contributions to the community. Let's give it up to John. Thanks. I wish they were here. The leader for this session is Marcos Portnoi. And let me pull up his bio. Marcos is the subject matter expert for all phases of the FIPS 140-3, 140-2 validation for cryptographic products for entropy source validations and for common criteria evaluations. He is the panel leader, and as the panel leader, he will be introducing the other members of the panel. So it's up to you now. You got it.
You're missing one, huh?
Yeah.
Shall we wait a few minutes because we are missing one? He might be entangled in another session. That was not intentional, it just came out. I put the pictures of everybody here so you can blame the proper person. And blame is a term from Git. Has nothing to do with the other definition of blame. Well, I hope he comes. We'll make it work. Yeah. A couple more minutes and we can start. You look much younger. I think we're good to go, right? Yeah, let's get started then. Let's start this panel a little bit differently. I'm going to ask each of the panelists here to introduce themselves, and while they do that, to talk a little bit about their understanding of crypto agility and how they see it, how it applies to each of these areas that they have.
Okay. There you go. So if we think back like 12 months, the crypto agility has been a buzzword, right, to a lot of people, at least to me, because I saw that there are some workshops on the crypto agility, and the people talk about the transition to PQC. However, I think today I think crypto agility is beyond the PQC transition. Think about during the old days, the the application hard code cryptography in the application code. So for the application, there's no way to change crypto functions. Then later on, things changed. But we really need a further change, because every time we have something to deprecate it, we want to introduce new crypto tools that kind of shake the whole system, shake the whole protocols, and a lot of time, money, cost. So I think crypto agility is for any system to feasibility to adapt to the new crypto tools without the disruption in the operation and in the security. So furthermore, I think crypto agility means operational mechanisms in your environment. Whether your environment is a protocol, or your environment is a HSM, or it's an API, or software libraries, or you are application designers. And also, I think crypto agility also not only for the developers, and also for the practitioners, for IT administration, for the enterprise, for the people who use the third-party software. They all need to understand in their environment how they are going to think about the crypto agility to put a doable mechanism there to serve this purpose. That's my understanding now.
Yeah, hi, my name's working? My name is Jim Goodman. I'm the CTO of Cryptography. And in case you didn't know, for some reason, Lily Chen, fellow at NIST. So Lily gave a phenomenal overview of crypto agility and what it means and the implications of it and just how extensive it is. I'll present our perspective from the perspective of an HSM vendor. To me, crypto agility, I'm buried deep down the bowels of the ship, essentially. For me, it's the ability to provide just about any kind of cryptographic service up into the stack and having the APIs necessary to basically allow applications in that to reach down into my domain and to pull up the cryptographic functionality they require. And that's a little different than, some people might think of agility as being an abstraction. You don't want to worry about the details. You want to push a policy, not an algorithm. But for us, it's all about trying to be as flexible as we can and provide as much functionality up the stack as we can. And I think that that's value. Something else I think Lily touched on it too is one of the things with crypto agility is I don't think it's a point in time. I think that over time, we're talking about agility so we can transition to the PQC. But yeah, as Lily said, over time, we want to have the ability to keep evolving, right? I think the key thing about agility is evolution. We don't want to make static solutions or point solutions in time. We want to make systems that can grow over time and can adapt to whatever the current requirements are of the system in general.
Hi, good afternoon. I'm Russ Housley, and I've been working on security protocols in the IETF for many decades. And as part of that effort, when I was security area director, we had this effort to transition from SHA-1 to SHA-256. It was, simple. We thought, 5 years. Wow. I don't think we're done yet. But from that experience, I wrote RFC 7696, which is the guidelines for cryptographic agility in protocol design. And so that gives the guidance to other people coming along after us so that they know where to put algorithm identifiers, how to deal with suites, how to structure their protocol so that transition is possible. And it encourages, in addition to that, measurements so that when you're doing a transition, you can figure out when very few people are still using the old protocol so you can just turn it off. It's a hard thing to do, getting those measurements and metrics, but this has been done fairly successfully recently by the browser community, where they actually have been able to turn off some older cryptography, especially RC4, stuff like that, because they were able to demonstrate that less than 0.1% of the traffic was using it. Thank you.
Thank you. Lily, let me throw this one to you. What about potential challenges of crypto agility? from the point of view of history of the crypto agility, evolution of that, practical implementations, etc. Talk a little bit about that.
So the crypto agility is not a scientific problem. It's really engineering and financial and strategic challenge in many different ways. And I was the cryptographic technology group manager, and from 2012 to 2023, and I kind of received a call. I think you probably think shocked. It's about, oh, can we still use single desk? I said that, well, if you use single desk, don't bother to do the encryption. I said, why you want to do the single desk? The answer is we don't have the money to update our equipment. So this is not a single story, and because whether you can achieve the crypto agility really depends on what is the limit, right? So we can't say, okay, this is a requirement for the crypto agility, you need to achieve something, but really it's in your resource limitation how you are going to do the crypto agility. So the further challenge is the resource limitation. For example, in a piece of the hardware, right? If you want to implement both the current public key cryptography and also PQC, then there are, this size and the command or something. So like in TPM, many years ago, they even want to reuse some command for elliptic curves. So that means, this kind of very challenge that is about resource challenge. Another challenge I can see is that it's about the complexity. Russ mentioned about the cipher suite negotiation in a protocol. So I fully agree with the RFC said that it's not the more the better. The crypto agility really introduced some complexity. So the complexity is the enemy for security, right? And also the balance between this complexity and the security, and also you want to do the backward interoperability, right? So if some client went to a server and the server claimed, oh, I can only do something, and then this is the attack is possible. So the security is another challenge for the crypto agility. So for each of the environment, I think this is the two summary is the resource limitation, the challenge, and then is secure challenge.
Yeah, from the Asian perspective, I'll add to that the complications of the verification, right? Like, so the notion that the more things you put onto the pile that I have to support, because again, I'm looking from the perspective of providing services, the more complicated things get for me to provide that, and as Lily was attesting to, that introduces more opportunities for us to do something wrong and to introduce security vulnerabilities and like. So it's a pressing problem for us, and it's something we are very concerned with, but yet we understand the need for agility. We want to be able to provide that capability. So, but we have to find, as Lily said, the right balance between the right subset of algorithms to support that gives us the necessary coverage and malleability and flexibility to protect against future threats that we don't yet know and we want to be able to protect against. We want to have the ability to migrate and evolve into new kind of forms.
So implementing crypto agility implies that you have a cryptographic API that you can provide one or more algorithm underneath. So if you just think about a very simple security protocol, two peers, they want to talk. The first one's going to inquire in its environment to find out which algorithms are available, and it's going to structure the first message in the algorithm negotiation, and it's going to order its preferences of the ones that it supports, send that across. Well, there's actually a policy decision right then about which order do I put them in, the strongest one I support to the weakest one I support. The other side then has to inquire from its crypto API to find out which algorithms are available, and then pick the one that comes first on the first guy's list that it's willing to do. Again, you might have a support for algorithms that it's not willing to do, and again, a policy decision. Then they can select one that is good enough for both and proceed. But that algorithm negotiation also needs integrity protection. Otherwise, you have a downgrade attack opportunity. So when you're designing that protocol, make sure that integrity protection is available.
Everybody's hearing this, right? It's not just me, right?
I was wondering about that.
Okay.
They're having more fun.
I was kind of nervous here.
Mike, they want to ask some questions.
So I also work. There's a mic right
Microphone.
behind
You wanna be in the panel, please?
Oh, hey.
Oh.
Fantastic.
Introduce yourself.
So I'm sorry about this. I got in touch with Dr. Max, and he said he's not in San Jose anymore. So he said, why don't you sub in?
Why don't you sub in?
All right. So Richard Kisley, and so IBM Chief Engineer for the Hardware Security Module. So a little bit of an overlap with Jim, but do what I can. And so on crypto agility, on the challenges, I would just say, certainly you covered the HSM point of view. From the customer point of view on the mainframe, wow, the music is loud, isn't it? Yeah. Maybe there's a wedding downstairs, but there's on the mainframe a lot of legacy applications. There's obviously a lot of new applications and challenges with adapting that code. And what I'll say is certainly actions we've taken are inventing tooling that will help clients identify, the trigger word inventory. But agility itself is a trigger word. So, but the tooling helps people identify the algorithms they're using, where the keys are. But I've also seen some amazing tooling that will change applications during in the CI/CD pipeline. So it's enabling agility at areas of the stack that you might not expect. And I'll say that I think there's a lot of innovation happening on the road to helping people get agility.
He wants to join the panel.
My first question today is in context of PQC algorithms, whether agility means choosing one standard versus the other, Falcon versus something else. As cryptanalytic advances weaken or strengthen one or other algorithm, or is it that you stick with the algorithm, say it is ML203, and even in the face of cryptanalytic advances, you change the parameter set, the size of your keys, or something like that. So the question really is, how should we think of agility? How much freedom do we need to retain in implementation to update choices later on?
Question to me, right?
Anybody, but
To all of
I
us.
think you're the standards person, so it comes. And since there are two people from HSM community, the algorithms are complex, computations are substantial, and HSMs have limited computing power. So what is the partitioning? What sits in HSM? What goes to the server?
Well, you're not going to send anything to the server, right? If it's part of the core cryptography, I'm going to have to do it in the HSM, at least from the HSM vendor's perspective. I wouldn't look too cool if I had told you, that's great, but you should do that yourself, right?
Okay.
That's not going to fly.
Okay.
But that being said, I think you have to do both, right? Like, I don't know I can't look into the NIST crystal ball and know if they're more likely to change a parameter set to tweak things or if to come up with new algorithms. They've kind of given the impression that they're going to onboard new algorithms would be the intention, but I'm not sure. So we would want to have the ability to do both. And I think actually it's a bit of a fallacy that HSMs are constrained per se. They're far less constrained than like a an IoT device. That's where I'd really be concerned about crypto agility in that, right, is complying to that. Whereas I have a processor, I'm plugged into a wall, I have more flexibility in that respect. I mean, I don't know, from IBM's perspective, do you feel the same way in terms of it's not as constrained as people may think it is? We can adapt?
Well, the constraints are usually in the use case. Yes, we can put a software algorithm into the device, but if your use case is high speed, then you really want that in silicon. So the constraint a lot of device vendors share is getting the algorithms in hardware, and then that's an investment. And it's calendar time to get it to the field, and we identified that earlier. So.
There's actually a protocol component to your question as well. Like if you look at how we did the parameter part of picking an elliptic curve, we started by defining a parameter set that lets you actually name the equation for the elliptic curve, and if you the two parties agreed on the equation, then they had interoperability. And we said, that's too hard. Let's register some well-known elliptic curves and just pass an OID. And then in this last set of registrations, we asked NIST not to do that. Like for Sphinx Plus, when it became, SLH DSA, we said, just give us an OID for each of the parameter sets. And so if you agree on the OID, you've agreed on the entire description of the algorithm, as opposed to a little tweak at the bottom, and you had to, so it's much easier to see whether you have interoperability between two implementations that way.
The intent of the question was more that suppose I get...
Please use the mic.
The session's being recorded, so that we need the mic.
The intent of the question was more along the lines of your example. If I've deployed Sphinx and 5 years down the road, I decide that parameter set A is, for whatever reason, no longer adequate, and I need to switch to B or C, is that part of your
But at least in the algorithm negotiation, you know quickly from the top OID, not deep in the parameters, whether you can interoperate. John just spent the previous half hour talking about how algorithm implementations go through and finding out whether there are interoperable.
Hi, while we're on the topic, have you looked into the security categories as a mechanism for negotiation? Because I was looking into this, and actually they're quite powerful, because if I'm looking to, if Alice is going to have a discussion with Bob, say, she's going to be thinking, oh, I want to do it with some sort of security assurance. And, it might be conventional, 128-bit, 256-bit, whatever, or it might be PQC or whatever. And when you're looking at these things, being able to do path discovery and say, hey, I want a path between these 2 points. And it seems to me that we've got way past the point where I want to be saying, here's my bag of algorithms. I want to be saying, find me a path between these points and make sure it's this strength of conventional and this strength of quantum. And those security categories look like a pretty interesting starting point there.
But if you actually don't implement the same algorithms, you don't actually get interoperability.
Oh, details. Yeah, obviously you've got to but in general, just how many algorithms do we normally have in path discovery?
Take a look at your browser.
Yeah, well.
But I also think even with the OIDs telling you the mechanism, there's a lot of room for incompatibility to creep in with various encodings and key formatting.
Yeah.
Right.
Okay. Yeah, I just had a question. I was just wondering your input on crypto agility and kind of future proofing, and where I'm thinking about that because I've worked in this area a long time. Like I go back to like Java, for instance. It has this crypto agile API, right? Then this new thing like Chem comes out. Well, that's not in Java, right? We talked to the Oracle guys, and then they got a Chem API in there. But then, you know, there's the stateful hash-based signatures. Now you have this thing about state that you have to maintain. So like, we know new stuff is going to come, and that's not going to fit into like anything we have today. So is there any thoughts about how we make that stuff agile, or is that just a pipe dream and will never happen?
You're smoking something. Can you
Okay.
share? No, think about the change that just happened since the initial draft and where we are now.
Yeah, the
right?
context.
Where we added
in this,
context,
right? Yeah.
we added pre-hash. I mean, if you could predict these, then we can
Yeah, I know.
structure the API.
Yeah,
right?
so I'm just saying, there probably isn't a solution to that from a crypto agile perspective. I just thought maybe there's thoughts on that, or
Right.
maybe it's just not possible. Because when I hear crypto agile, I think, okay, so we want to put a system in place that's agile, but we know new stuff's coming that's not going to be agile. So then, I don't know.
Well,
if it
then
helps
you
us.
have to define a new API
Yeah.
or an extension to the API to deal with the new class.
Yeah.
And if you make it so flexible that you can do that quickly, then everybody's going to be upset with the overhead they're dealing with day to day until you make that change, right? So you can't make anybody happy. at the end
That's
of the
right.
day.
Yeah.
It's striking a balance.
Yeah.
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 Okay, so you talked about the problems. So what now? How do you solve this thing? So you talked about the protocols, the API, and etc. All right, let's say that now you have to do the thing. You have to implement the product that uses crypto agility. It has to be quantum agile. Sorry, and how do you go about defining the algorithms that you're going to use? How do you're going to implement those things? How they're going to use those things in protocols, maybe existing protocols, by themselves, so on and so forth. I'm going to throw that to all of you.
Go for it. I know you want to talk about protocols, Russ.
Yeah.
Well, I mean, the thing that we see happen over and over and over is that the specifications get written for the protocol to use a set of algorithms. We have come to the place where we separate the algorithms and the protocols so that every time you want to specify an additional algorithm, you don't have to rev the protocol document. So we've gotten better at that. But then different industry segments pick different algorithms with different key lengths and so on for use in their own community. So you need to make sure that the cryptographic API supports all of those so that the different industry segments that need to be interoperable within their own community can do so without perturbing the protocol or the implementations.
Let me ask you this. Do you think it's a losing battle to try and come up with the one protocol to rule them all, or should different industries splinter and come up with, this is the automotive protocol, this is the IoT kind of protocol? Just curious.
So I think it's more complicated than that.
Yeah.
Like there was a slide in one of the earlier presentations where they talked about encryption at layer 1, encryption at layer 2, encryption at layer 3, encryption at layer 4, encryption at layer 7. So at least we got to skip 2 of the layers.
Thank you, OSI. Oh,
Go ahead.
I think I've started to think that there is agility in space and agility in time.
Yes,
yeah.
exactly. And cost.
You used the example of browser. In the case of web browsers, the user of the browser trusts the Google or the Microsoft to choose the right encryption protocol.
Mm-hmm.
But a different use case, our State Department communicating with its embassies, they're not going to trust the provider of the link or channel to choose the right protocol. They probably will ask Lillian to advise what cryptography. So how would these APIs and controls evolve so that in different situations the control can be exerted by either the provider of the packaged software or by the user of that packaged software, etc. Is that issue that needs to be addressed? And that was one question. The other, I'll ask, you can comment, that currently there is a unified API that is in libOQS that it uses to test all the timing tests and functional tests of all the algorithms buried underneath. Is that the foundation of a common API and something like that? If not exactly, that has to be supported and endorsed.
So we heard earlier this week about PKCS 11 updates to add chems and support for algorithms that have long key generation times, like, build the whole HSS LMS tree. I think those kind of innovations are going to continue to happen. In your example of a provider maybe providing some encryption on its own, and a customer of that provider may want their own. We see that over and over in the financial community. They want a secure link. They expect that to be provided by the provider, whether that be through a VPN or whatever, and then they encrypt their own on top of it anyway. I think it's the belts and suspenders kind of a risk model. And each of them is running their own crypto API. Right.
I like when you talked about how protocols got to the point that they're now separating the algorithm from the protocols, such that you can get to evolve the algorithms and leave the protocol alone. What else? And protocols are kind of standardized by IETF, SPDM, so on and so forth. What else could standards do to help the crypto agility?
First, I don't think the NIST will standardize crypto agility. So, however, our goal is to accommodate different sectors. I know the sector is a too large word, and different kind of environment to get their crypto agility strategies. That's the point, like how the protocol will do the crypto agility, how to do the crypto agility in an environment, in a system, like how to make sure that the application is, can talk to the hardware and through the software libraries, APIs, and other things. So this is what NIST currently the goal to do, to make sure, I like that term, like the crypto agility sound like the future proofing. So this is a kind of task for everyone and for every kind of environment. So that's the goal for that. We need to each of the situation to come up the operational mechanisms to do the crypto agility.
And do you see NIST documenting that, like coming up with proposals for what those different areas would be and like enumerating them?
So the current plan for us, we just started this project. Well, if we can call it a project, we have several team members and we have some collaborators, is to say, okay, we will get some baseline to what really the crypto agility is supposed to do. And then probably at some point, we can have a workshop or something to invite the people in the different sectors, different environment, for the different platforms to come in to talk about their crypto agility kind of strategies and mechanisms, and also to see if they can share, because currently, the people cannot share their ideas about the crypto agilities, because it sounds like people talk different language, right? So this is kind of not a surprise, because everyone have their own understanding about crypto agility. So we hope we can get some kind of organized approach so that we can have the people to share their ideas.
Yeah, having a shared nomenclature would be very beneficial. Absolutely.
Vocabulary.
Yeah. Moses?
Hey, so one thing that I think about when I think about agility is there's like sort of the agility of individual pieces, and then there's the agility of the whole thing, right? There's like the agility of the whole society, the whole industry, the whole sector, or whole enterprise. Or I think this is obviously this is in a way the wrong time to ask it, but maybe not. If we were to take a look at, let's suppose that like these government mandates of transitioning by 2035 work out to have happened, right? Then I think in 2035 it'll be a good time to look back and say, where did we screw up in terms of our governance and our determination of how we're going to move forward and do these things that cause things to be slow? So imagine me asking that question about 2035, but now, what would you predict we're going to say in 2035? And is there anything we can do about it now to change course?
I think we did that when we did the SHA-1 transition, right? And I looked at that and I said, wow, that was actually a really small piece of the overall system, right? Wow, this one is like top to bottom, everything's touched, right? And so those lessons learned need to be applied, but I don't think we're going to look back and go, wow, that was easy.
I think we'll look back and there will be a lot of people who said they started too late based on the lifetime of the data they're trying to protect.
Yep.
And I also think there will be people that look back and didn't redefine protocols for agility for security level, which was a great suggestion. But there are a lot of places where there's no security level negotiated. You just, there are areas in payment networks where it's just hard-coded, this is what it's going to be. And I think that'll be one area that'll look back. Maybe we'll do a good job in areas of the payment network and in, transmitting payment industry instruments or financial messages, but I think there will still be areas of the payment networks in particular that will look back and say there's some missed opportunities.
Do you guys think that maybe, so does that mean that we should just bite the bullet and do everything we think we need to do now despite how owners have tasked that maybe? Right? Like is this the opportunity for us to just pay the price and try to sort this out now? Given we're going to pay a price anyways, so incrementally is it worth it?
You can't do it all at once.
Oh,
okay,
I
but you
agree.
also can't turn it off, right? And so you have to do the prioritization of addressing the record now, harvest later is more important than authentication, and you're just going to have to deal with that.
Yep. No, not arguing. I'm just playing devil's advocate.
But as you have to do the algorithms first, and then the protocols, and that. I mean, it's a layered system. So.
Yep. But do you build into those protocols? Do you add the extra complexities to deal with the notion of agility and the ability to evolve over time?
Absolutely.
There you go.
APIs as well, to the best forecast you can come up with, right?
Fair enough.
Right. I mean, chems are here to stay, so
yeah, get used to it.
Yeah, get used to it.
Oh, excellent.
Definitely agree. Everywhere you have the resource to pursue, you should pursue it.
Yeah.
And even if, blasphemy, even if quantum computers or a cryptographically relevant quantum computer doesn't come along, cryptography does change, and there's a lot of people expecting the current conventional algorithms not to last 15 years. Yeah. So building in that agility gives you the chance to withstand those changes as well.
And that,
We've always, I mean, DES, triple DES, AES, and now AES 256 and so on. It's going to continue to evolve. So while the patient's open, put as much agility in as you can.
yeah, exactly. Yep. You have a question?
So I think while NIST cannot deal with the agility, maybe they can help reduce the complexity of the algorithm. For example, KEM, key generation. I know there's implementer who think you can just store the seeds instead of the expanded key, and think that that's one thing that come up at the PKCS 11 discussion as well. So I think if we can store something that's smaller and does not require validation, that's much more helpful.
It also affects other layers in the system, like PKCS 8, right? So the way these things are going to have to be defined to move the private keys around between two HSMs, however you back them up, that's all got to be done. So, and in the hybrid case, I think you'll be taking that seed and combining it with the elliptic curve private key or the RSA private key to wrap them as one blob.
Yeah, about that, I like to comment actually. So the simplify the key generation does not mean that we want to have more different ways to do the key generation. Because in some of the situations today, I think introduce more different variants to do the same thing is not really help with the crypto agility. I think it's kind of opposite. So we have like, I think we need to have more communications between the protocol designers and the cryptographers to design the crypto algorithms. Right now, we at the very beginning, we think we want the PQC to be a drop-in replacement. Then we didn't find the exact drop-in replacement, and it's kind of different, like a key generation, the public key size, and the signature size, that kind of things. Then we need to communicate to the next generation of the protocol designers for the communication protocols, like a IP layer, transport layer, whether this is a real kind of limitation for the protocol design to accommodate a larger signature size, or it's just to say the way it has been. So this kind of communication is very much needed for the crypto agility and between the application developers and also the hardware developers. So this is kind of the we need to think about agility. We don't want to introduce the complexity. So that's the basic idea, I think, here.
Let me jump into that. So these PQC algorithms have been proposed for quite some time now. So there's the process of having them approved, standardized, and so on and so forth. And even before they were standardized, the CSNA has put up those deadlines, very aggressive deadlines. So by 2030, some algorithms, the legacy one, not legacy, the classic ones have to go away, have to adopt the PQC ones in place of this. That they put a deadline. They didn't care about whether they were approved or not. Make it happen. Make it happen. Right. So
that's what the White House does.
And then we run. And you just talked. Okay, so you just talk about we have to have talks about how to make this transition easier for those who have to implement those things and do the products. And you talked about some things that you are already doing. I mean, all of us, labs and people who work on the CMVP, NIST, etc. What else could we do to make this transition easier or not so much complicated?
That I I would say it's a billion-dollar question. So how to make the transition easier? And I would say that in the next some years and before we really can move away from the classical crypto systems, it will be very interesting time because we have both classical public key cryptography system in all the kind of applications, device, protocols, and also the PQC entered these kind of the place. So we have, people have more options, and there are many different ways to do the combination. And then, so in this case, I think it will be the real challenge, the crypto agility. If we can make the crypto agility during such an interesting time, then I think we can make the crypto agility anytime.
The motivation's there, is what you're saying. So we can't do it now, we've got serious problems.
We can't do it now, we can't do it ever.
Yeah.
That's what she said.
Do it now, we can do it forever.
Yep.
Okay, so it's solved. Let me talk about one solution.
Actually, that's an awesome summary.
Go.
I could try to answer that as well. Just what can we do now to enable a better crypto agility model or implementation going forward? And I'll just say one thing that people can do is to invest, to get involved in the IETF, to help with the interoperability testing, to get your products up there, get products changed, get into interoperability, and help support the NCCOE and the other efforts. And then I'll also put in a plug, get involved in your standards organizations, because it's going to take a lot of bodies, a lot of smart people, a lot of minds to transition the standards that we rely on.
And it would be great to have representation from all segments, right?
Absolutely.
So that everybody's at the table. Because what you don't want is 9 out of 10 people showing up, and that 10th person going, this doesn't work, I can't do this, and then everything falls apart.
Or they get left behind.
More likely.
Yeah.
Okay, I like that. Now let me ask a question about today. So I work for a lab, right, and we do module validations. And since the beginning of the process of getting those PQC algorithms in the line for approval, the vendors, they jumped in and they started trying to adopt those algorithms in the state that they were, in the competition state, such that when those algorithms became approved, they would already have something to show up. So the normal model that everybody used was a hybrid model. So we have the classical algorithms that are already approved. For example, CDSA, RSA digital signature, whatever, so on and so forth. Approved, so let's implement those in the modules, and then let's get those PQC algorithms, also implement those. They are not approved yet, but make them work together such that when they become approved, something happens. Something happens. Now the question is, what must happen? And we have builders here, builders of modules. So now we have 2 algorithms that are approved. The tests are already available, and you can get those PQC algorithms approved, right? So what now? Do we keep both? Do we deprecate one in some time? What are your thoughts? That's for everybody.
Yeah, I think hybrid is something that's probably here to stay. I think that we're gonna, like I said, keep evolving, right? So yeah, we need it right now so we could, or we needed it to be able to allow us to do a FIPS approved and a non-FIPS approved to move things forward. Now we need it to do so we can transition between classical and PQC. At some point, if classical gets deprecated, so be it, but we will have new PQC that we want to transition to. We want to keep that malleability and that adaptability. We don't want to be, some people are complaining we're putting all our eggs in the lattice basket, or, we should be using stateless hash-based signatures. Hybrid allows us to have both things in transition over time. So as we learn, as we get better, as we come up with new tools, new techniques, new onboard digital signatures, we can continue to, quote unquote, smoothly adapt and transition to them by having this kind of capability.
IBM, any thoughts?
I agree. Fantastic.
Don't have to have a complicated answer every time.
I agree.
Russ, any thoughts?
No, I agree with everything.
It's good to go. Okay.
I think, well, this is a kind of choice because in any case, we cannot require people to use hybrid mode, I guess. So this is it's just an option. But I think we still need to understand how much, because today in this morning's panel, it sounds like the hybrid mode didn't add a lot of burden, according to Margaret in that panel, to the performance. So we need to have everyone to check that result, and in a lot of situations, we want to understand in any kind of environment whether this hybrid can work, and without the sacrifice the performance. So that, I think, is always an option and for the people to use.
Okay, let me ask this. I'm going to start this question from the point of view of the module, and then we go for a full organization, if we can get there, if it makes sense. So, piggyback on the hybrid scheme. So when you're building your module, you have a classical algorithm, you have the PQC, which is not yet approved. It's still in the competition phase, but I want to implement those, both, right? So me as an implementer, well, how should I implement that PQC? It's not completed yet. So I get whatever it's there to implement. And when those algorithms were approved, most of them were as it was described during the competition, but one or two which had slight modifications. So anyone who implemented those at a certain state had to adapt a little bit to the way it is now. So this is one challenge, right? If you're doing software, okay. If you're doing hardware, well, trouble. My question is, okay, this is one challenge. What else, what other challenges do you see when you want to implement this crypto agility and you have a certain state, you don't know what's going to happen in 6 months, whatever? What are other challenges that you see?
So if you depend on a PKI, part of the challenge is getting the roots cut, deployed, distributed, and if you choose to do a pure route, then you have one set of issues. If you're doing some kind of a hybrid route, are you really going to transition twice? These are policy and cost decisions that really don't drive the technology, but ultimately, I think if we deploy hybrid routes, we will never see the classical part go away. And so what happens when this says, you know, ECDSA and RSA are not FIPS approved anymore? Does the HSM have to not be in FIPS mode to support those routes?
Yes. So we'll be stuck between a rock and a hard place, right?
Well, you just don't have any security claim for that part of the hybrid object.
But if it's a object, right?
Yeah, some modification is required because -3, at least the service indicator has to be modified. What once was approved no longer is. So
he's telling us we have 5 minutes left.
Yeah.
Right?
Well,
10 minutes,
yeah.
right?
Hi.
Yeah.
10 minutes. Right?
I have an interesting question. Like you guys have been reviewing since last 7 years, and you have like final 4 selected. Is it going to still continue, like you will come down to 2 and 1 finally and put a rating on that we'll start with this, then this is the fallback, next quantum algorithm, and probably go back then? I mean, you selected top 4 right now, but let's say first year you are approving this one. If that gets knocked out, your fallback plan until one of them will probably survive for a long time. Or you are allowing, like in the agility, you will allow any of these 4 to be used in the hybrid model.
I mean, if they're on the list of approved algorithms and you're using it, I mean, there's still some implications regarding hybrid, like Russ kind of touched on it, this notion of a bound object, right? Like, they're not 2 separable keys, they're one key unit, right? I would suspect that NIST would, if a break happened, they would deprecate that algorithm.
Yes.
I don't know what the implications are to the infrastructure if you start having to kick out key pairs because one component is now. Exactly. That's a difficult problem. I don't know the answer to that, to be honest.
Yeah, it's a difficult problem, right? When it happens.
I don't know. We don't know yet.
Yeah.
So the match continues then? I mean, are you going to bring it down to 2? And like, why 4? Like, why did you not stop at 8 then?
Say that again, the question again, why what?
I mean, there are like more than 80 algorithms submitted, right?
Mm-hmm.
So you are stopping at 4 right now.
Mm-hmm. Mm-hmm.
So, I mean, why not continue and stop at 2 then?
So how many do you think is a proper number?
That's up to NIST, right?
That's just the answer, right?
So can you say another number you think is more
1
reasonable?
is the best. 1 is the best. I mean, we have grand slams where we don't declare like 4 winners,
But those are
right?
different classes of algorithm. We have at least one, right? One digital signature, and then you have they have to have some encapsulation for encryption and so on and so forth.
I mean, you can have many, but they should be rated, right? This is the best, then second best, third best, and you keep going then.
I don't think that kind of comparison to rank the algorithm, like the first, the best, the second best will work. Each algorithm have their own advantage. For example, like performance, like something of the bandwidth resource. So I don't think you can make that kind of comparison.
So I mean, what are those parameters, I mean, where you can compare, like, they are not going to perform same in all the parameters, that, right?
I think NIST was pretty clear in their reports why they made the choices they made, and they explained why they wanted the heterogeneity that they went with, and why they chose, for example, Sphinx Plus, and why they chose Falcon, why they chose. I think that's well documented.
Yeah, you can read over the first round, second round, third round report about why we choose what we choose.
Yeah.
All right, thank you.
We only have a couple of minutes and 2 people in line.
Yeah, I wanted to go back to that question Russ just asked about what do you do if you have a hybrid cert and an HSN? Because actually it struck me that there's a new thing that we've got now, which is in the past, if you gave somebody a certificate, well, the certificate only had 1 key in it, so it was implicit when you gave them that certificate that you would support the certificate algorithm. Now there can be more than 1. And so it seems to me that if it's a signature public key that's been handed over, well, then you can very easily have a situation where I give you a certificate, but I will only accept it, a signature request under MLDSA and not the ECC. For encryption, however, it gets a bit different because with encryption, you might have a case where I have a certificate with ECC and MLChem, and you might be saying encrypt under both.
So the idea that you've just proposed was discussed for a long time in LAMPS and rejected. I'd rather, given the amount of time we have, I won't enumerate them, but you and Max Paula are in the rough.
Yeah, well, I was just going to point out that if you do have FIPS telling you turn off your ECC thing, well, don't turn off the ECC decryption, please, because you might have some stored data that you want to decrypt at a future date.
We always have the stored data problem.
For legacy devices that are currently in the field and have lifetimes beyond 2030, that have a trusted execution environment that is not going to have the capability to implement post-quantum crypto, is there going to be guidance on how to deal with situations like that? Because right now we rely on the trusted execution environment to protect the integrity of the private keys.
Right, so the mixing with the pre-shared key is the best we can do right now. If you can't touch the code, right, you can't deal with that. And so there's extensions for TLS and IPsec and so on to do that. That's what we got.
Just end of life the devices before 2030.
That works too.
I'll ask the moderator if he
The
allows.
moderator's telling us we're out of time.
I'll ask you if you allow them 30 seconds for final thoughts. This is not a political debate, but
3 more
okay.
minutes. Oh.
Final thoughts.
Do you want to kick off?
Final thoughts.
Final thoughts.
Oh, final thought. Okay. I think this is a very good start on this topic in this conference. And so the NIST will work with the community to get to accommodate different kind of discussions about the crypto agility for the different sectors, for different application environment, so we can, move forward from here.
Yeah, I'd summarize by saying crypto agility is really hard. Best we get started on it sooner rather than later. And I think as we've seen, just listening to the issues and the concerns, even things that are relatively simple are going to be difficult. So I don't see any point not getting going, and supporting Lily and doing her crypto agility white paper, I think is a good first step on that path, as well as from an implementer's perspective, coming up with architectures in that we think are going to be capable of handling the agility perspective from our point of view, looking up into the stack, trying to provide as much capability as possible is probably what we'll end up doing short term.
So in an implementation, crypto API is necessary to step into getting to crypto agility, but so is the governance and setting those policies, and those are going to be done on an industry sector by sector basis. And those are political decisions and cost decisions. So those discussions need to start real soon.
I'll just agree that crypto agility is hard, and I'll just restate that there's a lot of tooling that can help with that and innovation in the tooling space to look for, and I think more will come in that area. And then I'll repeat my exhortation to join the standards bodies and join with your perspectives and help us all to a better place in the standards.
Thank you.
Yeah, thank you very much.
I'd just like to comment that it is a rare privilege to have such incredibly important information delivered straight from the most important people involved. And I just personally can't thank you enough, and I think we ought to give another hand. Let's go.
Thank you.